Most people think humans believed the Earth was flat until Columbus sailed west and heroically fixed everyone's geometry. That story is dramatic, cinematic, and completely wrong. Columbus didn't prove the Earth was round. He mostly proved that confidence and bad math are a dangerous combo. Humans had already figured out Earth's shape almost 2,000 years earlier, and they did it without satellites, rockets, or Google Maps. They did it with shadows, stars, ships, and one extremely committed librarian. So, when did humans realize Earth is round? The short answer is, very early. The better answer is a detective story stretching across civilizations. And by the end, you'll see why this idea survived empires, wars, and very stubborn opinions. Let's start where this myth usually begins. Ancient people were not idiots staring at the horizon, confused by circles. They were sailors, farmers, traders, and sky watchers with elite pattern recognition. They noticed things because survival depended on noticing things. If weather changed, you noticed. If stars shifted, you noticed. If your crops failed, you definitely noticed. And once people began moving long distances by sea, one pattern kept repeating. Ships approaching from far away didn't appear all at once. First, you saw the top of the mast, then the sails, then the hull. If Earth were flat, ships would just get smaller. Instead, they seemed to rise from below a curved edge. That's clue number one. Not proof yet. But a very suspicious clue. Then came the moon. During a lunar eclipse, Earth passes between the sun and moon. An Earth's shadow falls across the moon. That shadow is always curved. Always. No matter the season, location, or your mood. A circular shadow from every angle strongly suggests a sphere. You can fake a circle from one angle with a plate. You cannot fake it from every angle unless your object is round. That's clue number two. And this one is stronger. By around the 6th to 4th centuries, BCE, several Greek thinkers were already discussing a spherical Earth. Pythagoras gets mentioned a lot, though evidence is patchy. Plato supported the idea. Aristotle gave practical arguments people could test. He pointed to eclipses. He pointed to changing star positions as you travel north or south. Some constellations rise higher, others disappear. On a flat Earth, that behavior makes far less sense. On a sphere, it's exactly what you'd expect. So by Aristotle's time, educated circles were not asking, is Earth flat? They were asking, how big is this sphere? And that question unlocked one of the greatest science flexes in history. Enter Eratosthenes, librarian of Alexandria, mathematician, geographer, professional destroyer of bad estimates. Around the 3rd century BCE, he heard that in Syene, on the summer solstice at noon, the sun sat directly overhead. How did people know? Deep wells were lit straight down. Objects cast almost no shadow. Meanwhile, in Alexandria, same date, same approximate time, objects still cast a small shadow. Eratosthenes measured that angle, about 7.2 degrees. That's 1/50th of a full circle. If the angle difference between the two cities is 1/50th of a circle, then the distance between those cities must be 1/50th of Earth's circumference. So he took the distance between Alexandria and Syene, multiplied by 50, and got a circumference surprisingly close to modern measurements. No rockets, no drones. Just geometry, sunlight, and refusing to be lazy. Think about how wild that is. He measured the size of the planet while standing on it. That's like measuring an entire stadium while blindfolded inside one seat row, and getting most of it right. The exact value depends on the unit conversion and historical distance estimates, but his result lands impressively near today's approximately 40,075 kilometers equatorial circumference. For an experiment over 2,200 years old, that is ridiculous accuracy. So, was the debate over? Not exactly. Knowledge spreads unevenly. It's one thing for scholars to agree. It's another for every village, kingdom, and later internet comment section to agree. But in major learned traditions, spherical Earth stuck around. Greek science carried forward into Roman thought. Writers like Strabo and Ptolemy treated Earth as a globe. Then late antiquity and the medieval world inherited, translated, and developed these ideas further. And this part matters because a popular myth says the Middle Ages believed Earth was flat. That's mostly modern fiction. In medieval Europe, educated scholars generally accepted a spherical Earth. You can see it in textbooks, university curricula, and theological works. Thomas Aquinas references the Earth's roundness as common knowledge. Dante's Divine Comedy assumes a spherical world structure. Sailors navigated with celestial systems that only make sense on curved geometry. In the Islamic Golden Age, scholars advanced astronomy, geography, and trigonometry, all of which depended on spherical assumptions for useful accuracy. Al-Farghani's measurements of Earth's circumference circulated widely. Later, Latin translations spread this work into Europe. So, no, Columbus was not bravely arguing against a flat Earth church council. That scene is historically shaky at best, and mostly invented in later storytelling. So, what was Columbus actually wrong about? Distance. He underestimated Earth's circumference and overestimated Asia's eastward reach. In simple terms, he thought sailing west to Asia was much shorter than it is. If the Americas weren't there, that expedition could have gone very badly. He wasn't proving Earth is round. His educated critics already knew it was round. They thought his trip was too long and too risky. And on that specific point, they were right. History gave Columbus a continent-shaped bailout. Then why does the flat until Columbus myth survive? Because it's a clean story. One hero, one ignorant crowd, one dramatic correction. Humans love that format. Reality is messier. Real knowledge is usually cumulative. Tiny observations stack across centuries. Someone notices a shadow. Someone logs a star. Someone refines a map. Someone checks the math. No trumpet fanfare. Just generations of nerds quietly being correct. And honestly, that's my favorite genre. Let's zoom out. How did humans realize Earth is round? Not in one moment, in layers. First, visual clues from sea horizons. Second, eclipse shadows. Third, star position changes by latitude. Fourth, formal geometric measurement by Eratosthenes and others. Fifth, long-term transmission through Greek, Islamic, and European scholarship. This is how robust knowledge forms. Cross-checks, independent methods, different cultures, same conclusion. That's powerful. Now, to be fair, not every person everywhere believed the same thing at the same time. Belief maps never look neat, even today. With live satellite feeds, people still debate basic facts online. So expecting perfect consensus in the ancient world is unrealistic. What matters is where evidence-based scholarship landed. And on that question, the spherical Earth was old news, long before the age of exploration peaked. Here's another interesting detail. Ancient scholars didn't stop at Earth is round. They asked practical follow-ups. How big is it? How do we map it? How do latitude and longitude work? How do we predict seasons and daylight length? Those questions created tools for navigation, calendar systems, and eventually global trade. So this wasn't abstract philosophy. It was infrastructure for civilization. A round Earth model helped people move goods, empires, and ideas. You can draw a straight line from those early measurements to modern GPS. Different technology, same geometric backbone, and if you want a quick reality check, you can do yourself. Watch a ship disappear hull first at the coast. Track how different stars appear when traveling north or south. During a lunar eclipse, look at Earth's curved shadow. Put a stick in the ground at local noon and compare shadow angles with someone far away. Congratulations, you are now doing ancient science. No lab coat required. There's also a deeper lesson here. People often imagine the past as dark and confused until modernity arrived with answers. But the past was full of rigorous minds solving hard problems with minimal tools. They lacked satellites, yes. They did not lack intelligence. If anything, they had less noise and more patience. No notification pings, no doom scroll, just sky, stone, geometry, and very long attention spans. Honestly, kind of terrifying.